Morning to 100% here. And the today's presentation we are going to discuss about the unit mobile computing subject unit number 1, particularly the topic about the MAC protocols, how what all the MAC protocol issues are faced by the mobile computing. First issue that is faced by the MAC protocol is a hidden terminal problem. Hidden terminal problem in the sense one receiver will be there, two sender will be there. One sender is not closer or it is not viewed by the another sender. So because of that, what kind of problem it will arise? So this is a real example gives that A sends the data to B. C cannot receive the data which is forwarded by node A. C wants to send the data to B. C senses as a free medium because when node C is trying to send the data to B and node A is sending the data to B, this portion the transmission medium is available, as well as this portion of transmission medium is available. Even though it is a wireless medium, it is available, but when the receiver receives the data from both node A and node C, at the time of receiving there is a possibility for the occurrence of the collisions. So that is called as the hidden terminal. Node A is a hidden terminal for C, vice versa. C wants to send the data to B, C senses the medium as a free. Collision occurs at the venue B. A cannot receive the collisions. A is hidden for C and C is hidden for A. That is what given here. Followed by that, the second issue is the exposed terminal problem. B sends the data to A. C wants to send the data to D. See, B wants to send the data to A. C wants to send the data to D. But node B and node C are in the coverage range. So even though the direction of data transmission is completely different, B is sending data to A and C is sending data to D, since these two nodes are coming under the coverage range, it cannot send the data to A and D. Because of this kind of issue is called as exposed terminal problem. That is given as B sends to A, C wants to send the data to D. C has to wait because B is sending the data to A, but since the node C is coming under the coverage range of B, it is not able to send the data to D. But there is no communication between B and C. Since it is coming under this signal coverage range, it sends the data to, it cannot send the data to D until the data transmission gets completed between node A, B and A. C node has to wait for its turn. So since A is outside the range of C, waiting is not necessary. As I told that it is outside the range of A and B, outside the communication range of A and B, but still it has to wait. So C is exposed to B. Hidden terminal and exposed terminal problem. Here the diagram says that A wants to send the data to B, C senses the channel and no idea for transmitting the transmitting to A. C initiates the transmission to F. Collisions at node B and C and A are hidden terminal for each other. What we have discussed in the previous slide is given here as a diagrammatic representations. A is sending the data to B, C is sending the data to B, but B and C are coming under the coverage range. It has to wait. So that issue, as we mentioned, that it is called as exposed terminal problem. So hidden terminal problem is when node C is trying to send the data to B, there is a possibility for the occurrence of hidden terminal problem, collision at the node B. Near and far terminal problem. As always, we know that when we are sending the data to the sender and receiver are very closer to each other, the communication, the interruptions communication will be very effective. The interruption is very less. When the data has to travel for a longer distance, there is a possibility for the occurrence of disturbances. The external interferences may disturb the data. So because of that, the data which is traveling for a longer distance, there is a possibility for the occurrence of collisions. So terminal A and B send, C receives. The signal of terminal B hides A's signal. C cannot receive the signals of A. There is also a severe problem for CDMA networks, that precise power control required. So these are all the points comes under the near and far terminal problems. So next point of what I am going to discuss is classifications of wireless MAC protocols. So several classifications are there. fixed assignment scheme, or random assignment scheme, or reservation based scheme. In the fixed assignment scheme, we are having the content called fixed frequency division multiple access, time division multiple access, and code division multiple access. So these things comes under the circuit switched network. Next one is a random access scheme that consists of Aloha and CSMA. So this random access scheme comes under the connectionless packet switched network. Third one is called as the reservation based scheme that considers the MESA protocol, that is the CO packet switched protocol. So about the fixed assignment scheme we have discussed in the previous video. In the today's presentation, we are going to discuss about the random access scheme, particularly about the CSMA, that is carrier sense multiple access. Generally, carrier sense multiple access in the sense when the data is transmitted between one node to another node, the sender node will senses the medium, whether the particular medium is idle or not. If the node is idle, it will try to sense the data. If it is busy, it has to wait for a particular amount of time. That may be a random amount of time, and then it tries to sense the medium. At the time of sensing the medium, if it is idle, it will try to sense the data. Otherwise, it has to wait for its turn. So that is the logic behind the CSMA mechanism. Carrier sense. In many situations, stations can tell if the channel is in use before trying to use it. As it told that if the transmission medium is busy, it cannot sense the data. There is a possibility for the occurrence of collisions. In order to avoid the collisions, we are trying to sense the medium whether it is available or not. If the channel is sensed as busy, no station will attempt to use it until it goes idle. As I told that if the transmission medium is accompanied by some other transmission, we have to wait for our turn. So for that, we are trying to send some signal, and we will try to identify whether the medium is available or not. This is the basic idea of the carrier sense multiple access protocol. CSMA protocols, there are different variations of CSMA protocols. One persistent CSMA, non-persistent CSMA, P-persistent CSMA. One persistent CSMA, if the medium is idle, the persistency is nothing but how much amount of time we are going to wait. There is a possibility the time can be a random or it can be fixed. So that can be decided by using the three variations of CSMA protocol. One persistent, non-persistent, and P-persistent CSMA. One persistent CSMA, if a medium idle, it transmits. If the medium is busy, wait until it becomes idle, then transmits with the probability of value 1. If collision occurs, waits for a random period of time and starts again. So there is no, if it is a one persistent CSMA mechanism, there is no estimated calculations for rechecking that node, whether it, when rechecking the transmission medium, whether it is available or not. So non-persistent CSMA, if the medium is idle, it will transmit. Otherwise, it wait for a random amount of time before retrying. Thus, station does not continuously senses the channel when it is in use. So the difference between one persistent and a non-persistent is randomly it will check. One persistent, as far as the one persistent CSMA is concerned, randomly it will check. But in the case of non-persistent, randomly and continuously it will not check. It will check. It will check based on some amount of time. P-persistent CSMA is nothing but when a channel is idle it is detected, transmits the packet in the first slot with the probability 1. Suppose if the transmission medium is busy, it will wait for its slot and it will calculate the probability of Q is equal to P minus 1. That is a difference from the one persistent and non-persistent. We discussed the one persistent CSMA. One persistent CSMA, the protocol listens before it transmits. If channel is busy, waits until the channel becomes idle. If the channel is idle, certainly it can transmit the data. If the collision occurs, waits a random amount of time and starts all over the transmission again. It is called one persistent because the station transmits with the probability of 1 whenever it finds the channel is idle. It will not wait for the P is equal to Q plus 1 or P plus Q is equal to 1 and all. Whenever the probability value is 1, it will tries to switch the data. So the CSMA protocol, if the packet is ready, it will check whether the channel is busy or not. If it is busy, it will compute the random back of integer value. If it is not busy, it will transmit the data, wait for a round trip time. If it receives the positive acknowledgement, then it tries to send the next packet. Otherwise, Again it will check whether the transmission channel is busy or not. So this is the graphical representation between the CSMA and AlogANet. AlogANet we have discussed in the previous slide. Comparing to the AlogANet, CSMA gives the better performance comparing to the AlogANet. CSMS CD, CSMS stands for carrier sense multiple access. CD stands for the collision detections. In case of any collision occurs, it will be detected by using the mechanism called CSMS CD. Problem: when the frames collided, medium is unusable for duration of both frames. For a long frames, a considerable waste. What if station listens while transmitting? If medium is idle, transmits, otherwise it will wait. If the medium is busy, wait until idle, then transmits the probability with 1. If collision detected, transmits brief jamming signal and abort the transmissions. In case of any collision occurs, it will completely abort the communications or the transmissions by jamming the complete transmissions. After aborting, wait for a random amount of time and then it will try to send the data once again. CSMS CD performance wasted capacity are restricted to time to detect collisions. The time to detect collision is lesser than 2 into maximum propagation delay. A rule in CSMS CD protocol is frames are long enough to allow collisions or detections prior to end of transmission. So this is how the detections occurs. The first frames is transmitted, that is a transmission period, and this is the contention period. Then followed by that, the next frame is trying to send. Then it comes under the contention slots. Then frames are detected. In case of if it is idle, the data transmission takes place. If it is busy or if any collision occurs, the complete transmission will be aborted by sending the jamming signal, and it will tries to retransmit the data after a random amount of time. So CSMA CD can be one of 3 states, whether it may be in the contention state or it may be in the transmission state or in idle state. So with this note, I would like to close my sessions. Thank you for the presentation. Thank you for watching.